Hi students, welcome to UGC E-Pathshala. I am Dr. Sangamitra, Assistant Professor. I am here to discuss about the topic on wastewater treatment in food industries. Ever-increasing industrialization and speedy urbanization have significantly increased the rate of water pollution. The untreated effluent from industries pollutes the water resources, which pose a severe threat to human beings and marine lives. Food industry, one of the fastest growing industrial sector, which use huge amount of water for various purposes from raw material to final product. The water used may be of general purpose water, processed water, cooling water and boiler feed water. General purpose water is for washing and sanitizing raw materials, processing equipment, plant facility and ancillary equipment. Processed water for cooking or processing the product must be potable in nature. Cooling water, not necessarily potable, is used for non-food contacts. Due to diverse consumption, the amount and composition of wastewater from food industry varies considerably. The constituents of food industry effluent are organic matter, suspended solids, acids, alkali, inorganic salts, heated water, color, toxic substances, microorganisms, foam producing substances, fats and oils, phosphorus, chlorides, etc. Hence, the primary aim of wastewater treatment is to remove the suspended particles before leaving the effluent to the environment. So, on completion of this module, you will be able to analyze the possibility of wastewater from different food processing industries and identify the different methods of wastewater treatment. Do you know the sources of wastewater? Yeah, let us see. Wastewater from food processing industry is different from other non-food industries in a way being readily degradable and free from toxicity. Food processing sector can be classified into four major groups such as fruit and vegetables, meat, poultry and seafood, beverage and bottling and dairy operations. The sources of wastewater may be from meat and poultry processing, beverage industries, fruit and vegetable processing, dairy processing, fish processing, corn milling, fats and oils, sugar and flavor industry. A huge amount of water is consumed for processing of foods in the above said four sectors. These waters are to be treated for a safe disposal to the environment. So, from the given table, you can view the estimated volume of wastewater produced from different food processing industries. The food processing wastewater shows a huge variation in BOD and COD level, total and suspended solids, oil, starch, sugar, color, preservatives, salts and minerals. This is due to the usage of different additives used for different food products. Food industry wastewater constitutes COD, BOD and suspended solids of 11,220 mg per liter, 6,860 mg per liter and 2,210 mg per liter respectively. It is also reported that the food industry wastewater is easily amenable to physicochemical treatment. The treatment methods can be used individually or in combination to remove moderate to high degree of chemical oxygen demand, biological oxygen demand and suspended solids from the food processing wastewater. Discharge of untreated wastewater into sewage system makes it difficult and expensive. Similarly, discharging untreated water directly into environment leads to numerous health hazards to humans, animals and marine organisms. Hence, the wastewater needs to be treated before discharging. The wastewater treatment methods are broadly classified into physical, chemical and biological methods. The physical methods include screening, sedimentation, flotation, filtration and centrifugation, whereas the chemical methods include coagulation and flocculation. First, we will discuss about the physical methods of treatment. So, in that we will see about screening. Screening is the first process carried out in wastewater treatment. The presence of large solid would interfere the next process or damage the equipment. A screen is a device with uniform size openings used to retain the solids found in the wastewater to the treatment plant. The screens may be of three different sizes, such as coarse screens, that is 6 to 150 mm, fine screen 1.5 to 6 mm, and very fine screen 0.2 to 1.5 mm. Communitors and grinders are also adapted to supplement coarse screening in order to reduce the size of particles. Communitors consist of a rotating slotted cylinder and blades. As the cylinder rotates, the blade cuts the size of particle until they pass through the slot openings. Grinders consist of two sets of counter-rotating intermeshing cutters that trap and shear solids into wastewater into a reliable particle size of 6 mm. The shafts counter-rotate at a different speeds to clean the cutters. In case of fish processing industry, simplest type of flow-through static screens with 1 mm openings are used. The tangential type screens are static type but less prone to clogging due to the flow of wastewater. Screening being used more frequently in small scale fish processing plants together with very simple settling tanks. The next method is the sedimentation. This process removes the suspended solids in the wastewater by gravitational settling. It works based on the difference in density between the water and the solid particles. The solid particles tend to settle at the bottom due to its higher density than water. Sometimes the term sedimentation and settling are used interchangeably. Sedimentation process can be used as both primary and secondary treatment for separation of solids generated during the biological treatment such as activated sludge or trickling filters. To carry out the gravitational settling, sedimentation basins are constructed in different sizes and shape as required. The basin consists of 4 zones. They are the inlet zone, settling zone, sludge zone and outlet zone. The incoming wastewater is distributed uniformly throughout the inlet zone to the tank. The heavier particle tends to settle in the settling zone and collected in the sludge zone at the bottom of the tank. The water without solid is collected in the outlet zone. Next topic is flotation. Flotation is a unit operation that removes suspended solids from the liquid phase. The most common method of flotation technique is air flotation, and the techniques may be further classified as dissolved air flotation and dispersed air flotation. In dissolved air flotation, the wastewater is initially pressurized with air in a closed tank. After passing through a pressure reduction valve, the wastewater enters the flotation tank. In the flotation tank, due to sudden reduction in pressure, minute air bubbles of around 50 to 100 microns in diameter are produced. The bubbles attach to the suspended particle, and the buoyant force of the bubble along with the suspended particle is great enough to rise to the surface, forming a scum layer. In dispersed air flotation, the gas is directly injected into the liquid phase, which causes the bubble formation. This method finds a limited application in treatment of industrial waste containing oil, grease and fine powders. The performance of these methods can be enhanced by addition of chemical additives. The advantage of flotation over sedimentation is that very small and light particles that settle slowly can also be removed more completely in a shorter period. Flotation can also be used to concentrate sludge obtained from biological process. The next method is the centrifugation. Centrifugation is one of the physical methods carried out for treating wastewater. In this process, centrifugal force is applied which separates the solids from the liquid. The device used for this purpose is called centrifuge, which employs high rotational speed to separate components based on difference in densities. A decanter centrifuge plays an important role in wastewater treatment, especially in food processing industries, separates the solid material from liquids. Usually, in a stream of wastewater, the high density component tend to fall to the bottom of the mixture while the low dense component remains on the surface. Due to continuous rotation of the decanter centrifuge, it increases the rate of settling and reduces the settling time. Another well-known method is the filtration. Filtration is often employed in wastewater treatment with or without pre-treatments by coagulation, flocculation and sedimentation for removal of flocks or solids remaining in effluents from primary and secondary wastewater treatment. Use of rotary vacuum filters for dewatering is the most common method of filtration of sludge. Granular media filtration is used for removal of total suspended solids, whereas membrane filtration for removal of suspended and dissolved solids. Membrane filtration works on the principle of selective permeability of one or more components of a liquid mixture through a membrane barrier. Dairy effluents are treated using membrane filtration methods such as microfiltration, ultrafiltration, nanofiltration and reverse osmosis. These methods are considered as energy efficient as compared to conventional filtration method. Similarly, for treatment of slaughterhouse effluent, ultrafiltration and reverse osmosis are employed. Next, we'll move on to chemical methods. Chemical methods of wastewater treatment involve chemicals which will react with a portion of the undesired materials. But the use of chemical additives creates difficulty in discharging huge amount of treated chemicals. The most commonly used chemical treatment process are coagulation and flocculation. These processes are employed prior to sedimentation and filtration in order to enhance the ability of a treatment process to remove the particles. So the next method is coagulation. Coagulation process by which colloidal particles are destabilized. Destabilization can be achieved through the addition of coagulants. It neutralizes the charges of wastewater and forms gelatinous mass to trap particles, thus forming a mass larger enough to settle or to be trapped in the filter. Coagulants with opposite charges to those of the suspended solids are added to the water to neutralize the negative charge on dispersed non-settlable solids such as organic substances. After neutralization, the suspended solid particles stick together and forms a slightly larger particles called microflocks. High energy mixing can be employed to ensure proper dispersion of the coagulant and to promote particle collision, which enhances the formation of microflocks. The formed microflocks are then removed using the sedimentation process. The most widely used coagulants for wastewater treatment are the aluminum sulfate, ferrous sulfate, ferric sulfate, ferric chloride. Chitosan is a natural coagulant used to treat wastewater from milk processing plant. Coagulant aid is when used with the main coagulant, it improves or accelerates the process of coagulation and flocculation by producing a dense and rapid settling flock. Commonly used coagulant aids are bentonite, calcium carbonate, sodium silicate, ionic polymer and non-ionic polymer. The next method is flocculation. Flocculation is a mixing or agitation process which encourages the particle to agglomerate into masses large enough to be settled or to be filtered from solution. It increases the particle size from submicroscopic microflocks to visible suspended particles. The collision of the microflock particles causes them to bond to produce larger visible flocks. Due to additional collision and interaction with inorganic polymers formed by the coagulant, the flock size continues to increase. Commonly used flocculants are iron, aluminium, magnesium and calcium. The coagulant aid are also to be added during the flocculation, which strengthen and bind the flock and also increases the settling rate. Once the flocks are fully formed, they can be removed from the solution they are in through traditional filtration methods. Design contact time for flocculation range from 15 to 20 minutes to an hour or more. The next method is the biological methods. This method uses microorganisms to treat wastewater. Microorganisms may be aerobic, anaerobic and facultative. In case of aerobic method, the organisms require oxygen to live. On the other hand, anaerobic organisms exist and multiply in environments that are devoid of dissolved oxygen. Facultative bacteria can switch to aerobic or anaerobic growth in an aerobic or anaerobic environment. The biological treatment method is advantageous in terms of capital cost and operating cost over the other traditional treatments like chemical oxidation and thermal oxidation, etc. Aerobic treatment of wastewater utilizes free or dissolved oxygen by microorganisms in degradation of the organic waste. The aeration process acts as oxygen sources for the growth of aerobic microorganisms, which will treat the organic matter and form sludge as the byproduct. Oxygen supply to the aerobes acts as an electron acceptor, due to which the biodegradation process can be significantly accelerated, leading to increased throughput capacity of a treatment system. Common methods of aerobic treatment include activated sludge, aerated lagoons, trickling filters, rotating biological contactors. Activated sludge is one such aerobic treatment method where it contains aerobic tank and a sedimentation tank. This method utilizes aerobic microorganisms suspended in the wastewater in the aeration tank. A part of the organic component is completely oxidized and the other inorganic substances provide energy to sustain the microbial growth and formation of biomass. The flocks are kept in suspension by air blown into the bottom of the tank or by mechanical aeration. The oxygen level in the aeration tank should be 1 to 2 mg per liter. The flock mixture moves from the aeration tank to the sedimentation tank, where it combines to form a larger particle that settle as sludge. Though the process is efficient, the constraint in the process is the large quantity of sludge produced at the end of the treatment. Trickling filter is another biological wastewater treatment method, consists of a tower filled with the sands, plastic shapes or wooden slats. Wastewater is applied either intermittently or continuously over the support media. The microbes attach to the media and form a layer or a biological film. Oxygen is supplied to the biological film either up or down through the media based on the temperature of ambient air and the wastewater. The air can also be forced into the media. The thickness of biofilm increases as new organisms grow. A portion of the film slough off the media. The sloughed material is separated from the liquid in a secondary clarifier and discharged to the sludge processing. Rotating biological contactors is a biological treatment process used in the treatment of wastewater. It is a film reactors which consist of a stack of rotating discs mounted on a horizontal shaft. The slowly rotating discs are partially submerged in the wastewater in the reactor. Oxygen is transferred to the wastewater by surface turbulence created by the rotation of the disc. The sloughed materials of biofilm are removed and discharged to the sludge processing. The next method is the anaerobic treatment method. Anaerobic method of wastewater treatment consumes less energy, space, and produces less sludge in comparison to the aerobic method. This method utilizes microorganisms to degrade biodegradable material in the absence of oxygen. The complex organic materials are hydrolyzed to simplified organics by the hydrolytic enzymes. The simplified organics are then fermented into organic acids and hydrogen by the fermenting bacteria. The volatile organic acid will later on converted into acetate and hydrogen by the acetogenic bacteria. Then the methanogens will use the hydrogen and acetic acid and transform them into methane. Microorganisms used in the methane producing process are Methanobacterium, Methanobacillus and Methanococcus. Anaerobic process is considered to be advantageous than aerobic process due to its high degree of purification, ability to treat high organic loads, production of small quantity of excess sludge which is normally very stable, and the production of inert methane as an end product. Commonly used anaerobic digesters or anaerobic filters, upflow anaerobic sludge blanket reactors, anaerobic baffled fluidized beds, expanded granular sludge beds, sequencing batch reactors, and anaerobic hybrid upflow anaerobic sludge blanket reactors. Let me summarize the points so far discussed. Wastewater from food industry contain huge quantity of total and suspended solids, oil, starch, sugar, color, preservative, salts and minerals. The discharge of untreated wastewater into sewage system makes it very difficult and expensive. The process of sedimentation removes suspended solids in the wastewater by gravitational settling. The most common method of flotation technique is by air flotation, and centrifugation process of wastewater treatment employs high rotational speed to separate components based on difference in densities. Coagulation process neutralizes the charges of wastewater and form a gelatinous mass to trap particle, thus forming a mass large enough to settle or to be trapped in the filter. Then flocculation is mixing or agitation process which encourages the particles to agglomerate into masses large enough to settle or to be filtered from solution. And then biological method of wastewater treatment use microorganisms to the wastewater.